I'm going to make a quick video on covalent bonds. I think it's a little confusing for students, so let's talk about it on the little whiteboard here. So take carbon. So you have two carbon atoms right here and here. So you know carbon, the atomic number is 6. So there's 6 protons. It only has 6 neutrons for some review, so the atomic number would be 6. You don't change the number of protons because that would change the atomic number. You change the atomic number, you're going to change the element. That doesn't happen, right? And that could be a test question. You can't change the number of neutrons. Then it creates an isotope. So carbon-12 has an atomic mass of, carbon-12 is normal carbon. It has an atomic mass of 12. If you had one more neutron, you have carbon-13. That's an isotope of carbon. You'd have an extra neutron. Carbon-14, and instead of, you'd have 8 neutrons, right? So you have 2 extra neutrons, and that's another isotope. These are regular carbon atoms, so they're going to have 6 protons and 6 neutrons, right? We're talking about bonding, and bonding has to do with electrons. So if we have 6 protons, we know we're going to have 6 electrons because there's 6 positive charges from the protons and 6 negative charges from the electrons. We fill the inner shell, so 1, 2. It's the same in both here. And then we're going to have 4 in the outer shell. Okay, now this is how bonding works. We have 2 carbon atoms. They're going to form a single bond. And then we have 1, 2, 3 hydrogen ions. So it's going to form 1, 2, 3, 4. So 4 single bonds. Why can it form up to 4 single bonds? It's because, well, it has 4 valence electrons, right? So 1, 2, the outer shell is going to contain 4. I haven't drawn those yet. So 4 valence electrons, the octet rule, right? It wants its outer shell to be full because it feels more stable that way. So if it shares, right, one single bond is sharing of a pair of electrons, right? So this carbon has to share one with this carbon has to share one with this carbon. These hydrogen ions, what's going on there? So in a ion, so hydrogen only contains 1 proton, no neutrons, and 1 electron. So a hydrogen ion would lose an electron, right, and be H+, like H+, right? Hydrogen would be an ion. But hydrogen has 1 electron. So it only has 1 shell. So if hydrogen has 2 in its shell, right, which is its outer shell, it'll be stable too because there's only 2 electrons in the outer shell. So what happens here? Well, this carbon is going to share an electron with this carbon, share an electron with this hydrogen, and this hydrogen. So that's its 1, 2, 3, 4 valence electrons. It's going to share each of those with each of these other atoms, right? So it shares one with this hydrogen, shares one with that hydrogen, shares one with this hydrogen, and shares one with this carbon. So this carbon will share one, okay? And then we draw the other ones. So 1, 2, 3, 4. And this will probably be bonded to other things too, but we're not going to draw that, okay? And then the hydrogen only has 1 electron. It's going to share it with this carbon. So what's happening? So effectively, this hydrogen is going to have 2 valence electrons, or act like it because they're sharing it. That's more stable. This will have 2 electrons, more stable. This will have 2 electrons, more stable because the inner shell only has 2 electrons. Now this carbon is going to functionally have 1, 2, 3, 4, 5, 6, 7, 8. Now it's got 8 electrons, right? So this is going to be more stable. So these are all happy here. And then this would probably bind, to more hydrogen ions, but we don't have to draw that in. So it would look like this. It would look like, okay, here's the hydrogen here. There's a hydrogen here. A hydrogen here, right? So each of those hydrogens would share an electron with this carbon, and then this carbon would be happy, and those hydrogens would be happy. So what does it look like when we draw out the formulas? It could look like this. So carbon's bound to 1, 2, 3, 4 hydrogens, 4 single bonds, right? Or here, 3 hydrogen bonds, 1 carbon bond, still it's 4 single bonds. It could have this carbon here, so we're looking at this carbon here. This carbon here, well, it could have a double bond with oxygen, a single bond here with oxygen, and a single bond with carbon, but still 1, 2, 3, 4. You're just sharing a pair of electrons here, a pair of electrons here, and 2 pairs of electrons there. So again, 1, 2, 3, 4 electrons on top of its own 4 electrons. It's going to be relatively stable, or 2 double bonds. So this is carbon here, double bonded with each carbon. So 1, 2, 3, 4 are going to be shared with our carbon in the middle. It's going to be stable. That is a covalent bond. Now, a polar and this is equal sharing. So this is a non-polar covalent bond. Now, if you have a polar covalent bond, I won't draw the rings and stuff again. So H2O. So oxygen has 6 valence electrons. So because it has 6 valence electrons instead of 4 like carbon, it can only form 2 bonds. It only needs to share 2 other electrons or get 2 electrons shared with it, and it will feel like it has a full outer shell. So the 6 electrons here. So we're going to share an electron with hydrogen. So this gets one shared with it, this gets one shared with it, and then guess what? It's going to have the outer octet. But the thing is, the only difference here is that the electrons are going to spend a little more time hanging out next to oxygen. So this is going to have, whether you want to write it like this or whatever, that negative dipole. Okay, so it's going to be a little more negative there. And down here, by the hydrogens, it's going to be a little more positive. Okay, so that's the only difference. Okay, so this would be a polar covalent bond. So if you have water as a solvent or whatever, or just a glass of water, the positive hydrogens would be attracted to the negative oxygens and vice versa. Okay, and then if you put something like dissolved with salt, right, like sodium chloride in a solution, well, what would happen there? Well, sodium ions, they're going to be attracted here, so they'll sit closer to oxygen, and then the chloride ions, because they have a negative charge, will sit closer to the hydrogens. And that's how it kind of sits in solution.